Hello everyone, welcome to Module 2 of the Database Management Systems class. In this module, we will look at the relational model, query by example or QBE, and relational algebra. Upon successful completion of this module, you will be able to explain the relational model's basic component, use query by example to retrieve data from relational databases, create calculated columns in query by example to display specific information, utilize functions in query by example to retrieve data from relational databases, and apply relational algebra to query a database. A recap of Module 1. In Module 1, we were introduced to database management. We defined a database as a structure that stores data about different categories or objects. A database is created using a database management system or DBMS. A database is made up of tables. Tables represent objects, which in turn represent entities. We also stated that a relationship is an association between entities. We also discussed the advantages and disadvantages of database processing. We saw that Berg IT Solution, BITS, which is one of the companies used in the case scenarios, had to move from a file system to a database processing with Microsoft Office Access. What is a relational database? Before we delve into relational databases, let's look at the different types of databases. There are four different types of databases, namely hierarchical, network, object-oriented, and relational. I have attached a document which details the history and differences of these different types of databases under supplemental resources in Module 2. Please endeavor to read it. So, what is a relational database? A relational database is a database that is based on the relational model. It is a collection of related two-dimensional tables. One of the distinguishing features of the relational database is relationships. A relation is a two-dimensional table. As was stated in Module 1, a table is a two-dimensional grid that contains rows and columns. Tables contain or represent entities. A column is also known as a field or an attribute. The row is also called a record or a tuple. A database also contains information about relationships between the entities. A relationship is an association between entities. Relationships are established between matching or common fields of the entities. In order for a table to become a relation, it must possess certain characteristics or elements. Each cell holds a single value. In other words, the entries in the table are single valued. Each column has a distinct name, that is, attribute name. No two columns should have the same name. So if we were to look at this table here, which say represents the students table, or a table which contains information about students. each of these fields has a distinct name. There's the ID number field, the last name field, the first name field, the major field, and of course the class field. No two columns of fields share the same name. And of course, going back to the first element, entries are a single value. If you look at each of these cells, there is none containing two values. So no cell should contain two values. No entry should have two values. All values in a column are values of the same attribute or data type. You should recall that a data type is simply the type of data contained in a field. So once we've specified the type of data for any particular field, then all the values being entered in that field or that column should be of that data type, of the same data type. The order of columns is unimportant, so it doesn't matter which column comes first or last. The database management system will simply process the information requested. Each row is distinct. So if you look at a row, the entirety of a row from the first field all the way to the last, this row right here is distinct. In other words, the row which contains the record about the student with the student ID number 1001 is distinct, is different from the row or column or record for the student with ID number 2125. So when you take a look at a row in its entirety, it is distinct, different from any other record. The order of rows is not important. Again, it doesn't matter which row comes first or last. The database management system will still be able to process the request for data and information. Occasionally, you may encounter a situation where a table meets all of the above mentioned requirements to be considered a relation except the first one. That is, some of the values or entries are not single valued. Such a structure is called an unnormalized relation. We will be discussing the topic of normalization in Module 4. One of the purposes of having databases is to be able to retrieve some information when the need arises. One of the ways of retrieving information from a database is by creating queries. A query is simply a question asked or presented in such a way that a database management system provides you with an answer instantly. The question has to be asked in such a way that the inquiry or query can be recognized and processed by the database management system. Queries can be created by using commands or by using a visual approach. Query, by example, is a visual approach to writing queries. With this approach, users ask their questions by entering field names and other criteria using an on-screen grid and obtain the results in a tabular form on the screen. Queries are created in Access using the query window. The query window has two panes, the upper and the lower pane. The upper pane contains the field list for each of the tables to be queried, while the lower pane contains the design grid, which is the area in which the format of the output, the fields to be included in the query results, the sort order for query results, and any criteria are specified. So let's take a look at what a query window will look like. I'm pulling up the textbook. Let's go to chapter 2, query by example. Query by example, and then let me pull this. So that's what a query window will look like. This right here is the upper pane, which contains the table and the field list. And of course, this is the lower pane, which is, of course, the design grid. This is the area where you dropped or select the fields which are required to retrieve the data or information which is needed. There are several types of queries depending on the type of information to be retrieved from a database. For the purpose of demonstrating query by example, we will limit the types of queries to simple queries, queries with simple criteria, parameter queries, queries with compound criteria, and queries with computed fields. We will be using the BITS Access database to create queries. Now, before we do that, let us look at how to create a database using Microsoft Office Access. The database design topic will be covered in detail in Module 5. Now, this is what the BITS database looks like. The question is, how did we get to this? And that's what we were trying to look at. How do you go about creating a database and have all of these tables in place? To create a database, you have to identify the objects, and of course that translates to the entities. You may recall that objects represent entities. And once you've identified the objects, the next thing you want to do is determine the primary key. You'll also be required to determine additional fields, determine the data types, determine the relationships between the entities. The BITS database has 5 tables or entities, and you can see the 5 tables here. Actually, this is something I just created, but the tables are client, consultant, order line, task, work orders. So this right here is not part of the database I created. We will create a table consultant. Now, in order to do that, as I said a while ago, you ought to be able to go through the database design process. And in the course of doing that, you're going to come up with what may be termed the consultant table structure. And it's something like this. And so your table structure will always specify the fields or columns and the data type. In the case of the consultant table, which of course we want to demonstrate how to create, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 fields or columns. And these are the assigned data types for each of the columns. We'll be talking a bit more about data types in Module 3. And of course, this is the information which ultimately goes into the table once it's been created. So to create a table, you want to, first of all, have the table structure in place. And once you have that in place, you go ahead and pull up Microsoft Office Access. So let's go ahead and pull up Access. Mine is already open, so I'll go to File and click on New. You want to click on blank database. A window pops up prompting you to provide the file name or the name of the database which you'll be creating. Let's go ahead and give it the name. I'll say BIT, since we'll have data underscore database. And below the text box for the file name is the path to which your database will be, the path to the area or location or folder where your database will be saved. In my case, it says the database will be stored or saved in my documents. Now, if you're comfortable and you're willing to save your database in this area, you'll go ahead and save it. If not, you can click on the folder icon to the right of the text box for the file name and navigate to the area where you want to store the database. I'm going to store mine or save mine in this area. What you want to do next is click on Create. Once you click on Create, Microsoft Office Access creates the database with a default table, which of course has the default name Table 1. This window right here is known as the datasheet view. To create the table, in other words, to put in place the layout or the structure of the table, you want to go to the design view. Click on view on the menu top left and then click on design view. A window pops up prompting you to provide the name of the table you're about to create. We're going to name the table consultant. Once you type in the name of the table, go ahead and click on OK. And that takes you to the design view. This is the area or window where you put in place the structure of the table. In other words, the field names, the data types, and of course the field size. The field size simply refers to the length of the field or the number of characters which can be contained in the field. And now I'll go ahead and create the table using this information right here. You can type each of these fields or simply copy and paste. I'll go ahead and copy and paste since that will be a bit faster. Now, by default, when Access creates a table, it assigns a default name to the first field, and the default name is usually ID, and also makes of that first field the primary key. We're going to delete that and put in place the first field, which of course is the primary key for the consultant table, and that's consultant number. And then change the data type from auto number to short text. Repeat that for all of the other fields: last name, first name, paste, short text, first name, I'll paste that over there. Data type is also short text, and then move on to street. Data type is also short text. City, data type is also short text. State, zip code as state, zip code as the data type for us is number, and then of course rate is currency. We'll change this to number, and then the rate, the data type for the rate field is currency. Now, for the most part, well, in other instances, you'll be required to go ahead and, as I said, specify the field size. But for now, we'll just leave it as is. And once you're through with putting in place or typing in the fields and the data types, you want to switch back to the datasheet view. So you go to View and click on Datasheet. Now you'll be prompted to save the entries you just made. Go ahead and click on Yes, and then you're taken to the datasheet view or window. This is the view, or this is the window where you go in and input the information or the records about the different entities for the consultant. So let's go ahead and do that. Customer number 19, last name is Turner, first name is Christopher. 19, hit the tab key. Christopher. What's the street? 554 Brown Drive. Let me copy that and paste. City is Tri-City. State is Florida. Zip code is 32889. 32889. Ours is 40. Rate is 2250. $22.50. And then you hit on the tab key to move to the next column. Let me fix that. Okay. The next record, consultant number is 22, Jordan Patrick. 22, Jordan as the last name. First name is Patrick. And the street city is Easton. State is still Florida. Zip code is 33998. Ours is 40.0. And rate 22.5. And then you hit the tab key to move to the next record. Client consultant number is 35, Alan Sarah. 35, Alan Sarah. The street is 82 Elliott Street. Paste. City is Liston. The state is, of course, Florida. Looks like all of these consultants live in Florida. Zip code is 34344, 3520. Ours is 35. The rate 20. Hit the tab key to move to the next record. Consultant number is 51, Shields Tom. 51. Shields, Tom, and the street for Tom is 37 Lincoln. City is Sunland. State, of course, is still Florida. Oh, I missed that. I'm gonna have to come back and correct this. So this is what I will do. Get this out of here. And then this right here. The state is Florida. Zip code is 39876, 10 and 15. Ours is 10. Rate is $15. And that's it. So once you're done with creating the first table, you want to go ahead and create the second and the third, and simply proceed and create as many tables as you may have in your database. At this stage, you want to close the table. And if you have to proceed to creating the next table, you simply click on Create, then click on Table, and start the process all over. So that's how you go about creating a table in Microsoft Office Access. To successfully create queries, you need to have a knowledge of the database. You need to know the number of tables within the database, and also know, or at least have an idea of the fields in the different tables within your database. To create a query, you need to add the table or tables needed and the fields to be displayed in the query. Click Create on the ribbon to display the Query tab. Click the Query Design button found within the Queries group under the Create tab. Once you do that, Access will display the Show Table dialog box and a new tab on the ribbon named Query Tool Design. Select the table in the Show Table dialog box that you want to use in the query. The table is determined based on the fields to be displayed in the query results. Click the Add button in the Show Table dialog box to add the table to the query. Close the Show Table dialog box. Next, to include a field in an Access query, double-click the field in the field list to place it in the design grid. If you need to add all fields in a table, double-click the asterisk in the table's field list. After you have added all the fields required, click the Run button in Results group on the Query Tools Design tab to run the query and display the query results. So let's go ahead and create a couple of queries. And we'll be creating simple queries, queries with a simple criteria, parameter queries, queries with compound criteria, queries with computed fields. That, of course, is a window which displays what a simple query will look like. We saw this a while ago in the text itself. So let's go ahead and look at how to, or demonstrate how to create a query. So let's create a query which lists the number, name, balance, and credit limit of all clients in the database. I will pull up my BITS database. Did I last go right here? Of course, I thought I had that. No. Textbook, dataset, demonstration, BITS. And so to create a query, you want to click Create on the ribbon to display the Create tab. Click the Query Design button. That's it right there. Once you click on the Query Design button, Access will display the Show Table dialog box. This is it right here. Now, for this query, we're going to be using the client table. So it's been selected because it's the first table at the top. And as I said a while ago, you determine the table based on the fields to be displayed in the query results. If you look at the question, it says list the number, name, balance, and credit limit of all clients. Once you see all clients, that of course implies you'll be pulling the information from the client table. So we'll go ahead and add this table to the upper pane, and then we can close the Show Table window. Now we need to add the fields which will provide us with the information we need. You want to go back to the question. You're looking at the client number, client name, balance, and credit limit. Client number. So to include a field in an Access query, double-click the field in the field list. Client number, client name, balance, credit limit. So I have included the fields, and each time you double-click on the field, it is added to the design grid. After you have added all the fields required, click the Run button in the results group. This is the results group right here. I'll click on the Run button. And this, of course, displays to us the client number, client name, balance, and credit limit as specified or stated in the question. And this, of course, is exactly what we have in our data, in our query results. Now let's move on to our queries with a simple criteria. Before we do that, let's look at a short method of creating a query which displays all of the fields in the database. So if we wanted to create a query which displays all of the information in work orders, we'll have to go again to the Create, Query Design, and then double click the work orders. Rather, click on that and click on Add. Because we want to add all of the fields in this table, instead of adding one field after the other, you simply double click on the asterisk. That displays all of the fields in the work order tables. Hold on, I missed that. Okay, work orders. So to add all the fields within a table, you simply double click on the asterisk, and that of course will select all of the fields within that particular table. Once you're done with that, click on run, and that displays all of the fields in this particular table. Let's look at the next type of query. It's a simple query with a criteria. Now we want to display the client number and client name for the client with client number 458. In other words, the condition to be fulfilled for the information we need is that the client number should be 458. So go back to our database, click on create, query design. I'll use the client table, I'll add that. I want the client number and client name, client number, client name. And the criteria is that the client number should be 458. So under the criteria row in the client number, I'll type 458. And then of course click on run. That displays to me the name of the client with client number 458. This of course is an example of a query with a simple criteria. Next, let's look at a parameter query. Now, sometimes you may want to create a query which you can always use. In other words, you want to put in place a query which gives you the ability to retrieve different types of similar information. So if you plan to use a query repeatedly but with different criteria, you might want to save a parameter query. And so in the next demonstration, we'll look at how to create a parameter query. So if we want to be able to pull up information for different client numbers, instead of specifying a client number here, you simply put in place square brackets and then of course typed a prompt. So I'll put right here I'll include my square brackets here, and then put a prompt or a message which will prompt the user to type in some specific condition. So I'll type enter or type client number and close with square brackets. Once I run that, I'm prompted to type a number. And in this instance, I can always pull up the names of just any client as long as I specify the client number. But let's go ahead and still use 5458, which is what I know. And so that's how you go about creating a parameter query. Now let's look at how to create queries with a compound criteria. When it comes to compound criteria, you're using the relational operators and or. So in the next query, we'll be using the task table, and we're required to list the task ID, description, category, and price for all tasks in the sum category, and the sum category should be priced more than $150. So it's got to be something like this. So go to our design grid, create, query design. We'll be using the task table, close the show table dialog box, and we need to use the fields task ID, description, category, and price. So I'll go to task ID, description, category, and price. Task ID, description, category, price. The criteria for the task ID is that it should be sum and the price should be greater than $150. So for under the criteria row in the task, since it's a string, I'll put that in single quotation marks, SOM, and then the task price greater than 150. Now in this instance, we're using two conditions. So we want to be able to display the task ID, the description, for which the category is sum and for which the price is greater than $150. So once you've put in all of the conditions in the design grid, you want to go ahead and click on run. And that, of course, displays to us the query results. Next, let's look at how to create queries with computed fields. A computed field is simply a field which is derived from a calculation or computation made based on information found within your database. And of course, to do that, you're required to put in place a formula. So let's create a query which lists the number, name, and available credit for all clients. And for that, we're going to use the formula available credit equals credit limit minus balance. And we'll be using the displaying the client number and the client name. And of course, as you must have noticed, we'll be using the client table. So go to create, query design, add client table, close the show table, client number, client name, and you place the calculated field to the column, of course, which is next to the last field you just entered. And the title for the calculated field is available credit. Now, if the space you have here is not enough for you to type in the formula, you want to right click within that and then click on zoom. A window pops up and within you can type your formula within that window. We'll type available credit colon. You don't use an equal sign here. Available credit, and the formula is credit limit minus balance. Credit limit minus balance. Now note that the credit limit and balance are fields found within your client table, and you want to make sure that you type these fields exactly as they are in the table. If they are not typed out exactly the same, you're going to have an error message. So let's double check and make sure that we have that right. So your credit limit minus balance, and then of course you go ahead and hit OK and click on run. This of course displays to us all of the clients and the available credit for all of the clients. So this is how you go about creating a query with a computed field. And a computed field is simply a field which is deduced or derived from information within our database. Now, once you're done creating a query, you can go ahead and close it. And when you close it, you're prompted to save the changes to the query. Do you want to save changes to the design query? Click on yes. And once you click on that, you're prompted to provide a name for the query. And if you're required to state a name, go ahead and type in the name. If not, simply click OK to accept the default name. So in a simple query, you're having to put in place conditions or criteria. And a criterion is simply a single condition that data must satisfy. Of course, demonstrated how to go ahead and put in place criterion. We demonstrated how to create a parameter query, which simply allows you to enter criterion when you run the query. Now, when it comes to queries with compound criteria using comparison or relational operators. And examples of relational operators are your equal, greater than, less than, greater than or equal to, less than or equal to, not equal to. So a compound criteria, you're using the and or conditions. Computed fields, again, you are creating using information from within your database to perform some computation. Functions. Some of the common built-in functions in Access are the count, which of course returns the number of records in the field, the sum, which returns the result of adding together all the records in the field, average, which returns the result of adding together all the records in the field and then dividing by the number of records, the max or maximum function, which finds the largest value in a field, the mean or minimum function, which finds the smallest value in a field, the standard deviation, which returns the standard deviation of a numeric field that tells you how tightly the data is grouped around the mean or average, the variance, which returns the variance of a numeric field with a number that represents how far the data is spread out. The function first displays the first record in a field, and of course the function last displays the last record in a field. Grouping. Grouping creates groups of records that share some common characteristic. For additional information about this, please see pages 48 and 49 of the textbook. Most often, the order in which the query results are displayed is not important. However, occasionally there may be the need to present the results displayed in a certain order. This could be ascending or descending. If the sort order is not specified, then the default sort order is the ascending order. See pages 49 to 53 of the textbook. Sometimes when creating queries, you will need to select data from more than one table at the same time. To do this, you'll need to join tables. Tables are joined based on matching fields in corresponding columns. When tables are joined, Access will draw a line called a join line between the matching fields in the two tables. A join line indicates that the tables have a relationship or that the tables are related. For additional information on joining tables, please see pages 53 to 56 of the textbook. An aspect of database management is ensuring that the information contained within the database is current. If there happens to be some change in the record of an entity which is represented in a database, the record has to be updated to reflect this change. For example, if a client moves, the new address of the client has to be updated to reflect the client's new address. A query can also be used to update data. When a query is used to update data, it is called an update query. Please see pages 56 to 57 of the textbook for additional information on how to use an update query. A query can be used to delete one or more records based on the specified criteria. For example, if a client for the BITS company placed an order for a service and then calls later on to cancel the order, that order can be permanently deleted from the BITS database by using a delete query in which the criteria specified is the order number. Please see page 58 of the textbook for additional information. A query can also be used to create a new table in either the current database or another database. First, a query is created to retrieve some information or results. Next, a make table query uses the results to create a new table. Additional information on how to use a make table query can be found on pages 59 to 60 of the textbook. Query optimization is the process of enhancing the efficiency of a database. Improved efficiency leads to rapid and optimal results or increased speed of search. A query optimizer is a database management system component that analyzes queries and attempts to determine the most efficient way to execute a given query. Optimization is a statistical process that occurs behind the scenes. The query optimizer cannot be accessed directly by users. Query optimizers are very useful for large databases. So in conclusion, we want to state the fact that a relational database is a theoretical way of manipulating a relational algebra is a theoretical way of manipulating a relational database. It is based on set theory, which is a branch of mathematical logic. Relational algebra includes operations that act on existing tables to produce new tables. Manipulating and retrieving data from relational databases through the use of relational algebra involves issuing relational algebra commands that act on existing tables to produce new tables. Examples of commands and operators used in relational algebra include select, project, join, union, intersection, subtract, product, and rename. The select command retrieves certain rows from an existing table, based of course on user-specified criteria, and saves them as a new table. The select command includes the word where followed by a condition. An example of a select command will be select client where client number equals 363. So what this command does is it selects the client number 363 from the client table. The project command causes only certain columns to be included in the new table. It includes the word over, followed by a list of commands to be included. The join command allows extraction of data from more than one table. When two tables are combined, the tables are combined based on the values in matching columns, also known as the join column. The new table which is created contains columns from both tables. The rows in the new table are a concatenation of rows from the two tables. There are two types of joins, the natural join and the outer join. The union of two tables, A and B, is a table that contains all rows that are in either table A or B, or in both table A and table B. The intersection of two tables A and B is a table that contains all rows common in both table A and table B. The difference of two tables A and B is a set of all rows that are in table A but that are not in table B. The product of two tables is the table obtained by concatenating every row in the first table with every row in the second table. Division is best illustrated by considering the division of a table with two columns by a table with a single column. The result of the division, which is also known as the quotient, is a new table with a single column. In conclusion, a relation is simply a two-dimensional table. Entries in a table are single valued. Each field has a distinct name. All values in a field are values of the same attribute. Order of fields does not affect queries. Each row is distinct and the order of rows is immaterial. These, of course, are the criteria which a table must meet in order for it to be qualified to be known as a relation. A relational database is simply a collection of relations. Unnormalized relation is a structure in which an unnormalized relation is a structure in which entries need not be single valued, but that satisfies all other properties of a relation. Query by example is a visual tool for manipulating relational databases. To include a field in an access query, place the field in the design grid and make sure a check mark appears in the field's Show checkbox. To indicate a criteria in an access query, place the criteria in the appropriate column in the design grid of the query window. To indicate the AND criteria in an access query, place both criteria in the same criteria row of the design grid. To indicate the OR criteria, place the criteria on a separate place the criteria on separate criteria rows of the design grid. To create a computed or calculated field in Access, enter the expression in the desired column of the design grid. To use functions to perform calculations in Access, include the appropriate function in the total row. To sort query results in Access, select ascending or descending in the sort row for the field or fields that are sort keys. When sorting query results using more than one field, the leftmost sort key in the design grid is the major sort key, and the sort key to its right is the minor sort key. To join tables in Access, place field lists for both tables in the upper pane of the query window. To make the same change to all records that satisfy a criteria, use an update query. To delete all records that satisfy certain criteria, use a delete query. To save the results of a query as a table, use a make table query. Relational algebra is a theoretical method of manipulating relational databases. The select command selects only certain rows. The project command selects only certain columns. The join command combines data from two or more tables based on common columns. The union command in relational algebra creates a table that will have all the rows from two tables. Two tables are union compatible when they have the same number of columns and their corresponding columns represent the same type of data. The intersect command in relational algebra creates a table with the common rows from two tables. The subtract command in relational algebra, also called the difference, creates a table with rows which are present in one table but not in the other. The product of two tables, also known as also known mathematically as the Cartesian product, is the table obtained by concatenating every row in the first table with every row in the second table. The division processes relational algebra divides one table by another table. Task to be completed. Please read chapter 2 of the textbook, that is pages 29 to 69. Take part in discussion 2. Complete quiz 2. Complete assignment 2. Complete test 1. Please take note of the due dates and plan accordingly.